Equilateral triangle is drawn on side of a square, but in next model they may also ask equilateral triangle is drawn on its diagonal, one of its diagonals.
Family of parallelograms. One is parallelogram, rectangle, rhombus and square. This is a parallelogram, this is rectangle, this is rhombus, this is square. Now let's understand about parallelity, equality and about diagonals and then angles. So when we talk about parallel, here all figures like parallelogram, rectangle, rhombus and square all have same property, as these all belong to family of parallelograms. So this is the major property or the primary property to be satisfied, that it must be a parallelogram. Okay, that is two pairs of opposite sides are parallel and equal. So that is always there. In all this should be satisfied. Then only that is called as a parallelogram. Next, equality. Here just opposite sides are equal. Here also just opposite sides are equal. But in rhombus and square, all sides are equal. Okay, not only just opposite sides, all sides are equal. Next one, about diagonals. In parallelogram and rectangle, diagonals bisect each other. But one difference between them is, here diagonals are not equal in parallelogram, in rectangle diagonals are equal. And one more common thing is, in parallelogram and rectangle, diagonals are not perpendicular to each other, which means diagonals bisect but not at right angles. That is about diagonals. Next, rhombus and square, if you see, diagonals bisect and at 90 degrees and equal as well. So in parallelogram and rectangle, diagonals bisect but not at right angles, and also they are not equal. I mean in the parallelogram, one by one. In parallelogram, diagonals bisect but not at 90 and they are not equal as well. In rectangle, diagonals bisect and not at 90 and they are equal. And in rhombus, diagonals bisect at 90 and they are equal. Square, diagonals bisect at 90 and they are equal. Okay. Next, coming to angles. Here opposite angles are equal in parallelogram and adjacent angles are supplementary. Here in rectangle, same thing it is followed, like opposite angles are equal and adjacent angles are supplementary as it is a parallelogram. But one more additional property is each angle is 90, but in parallelogram we are not sure each angle is 90. Okay, so if a parallelogram with one angle is 90, then it is called as rectangle directly, correct? You understood, Radhika? Here, opposite angles are equal and adjacent angles are supplementary to each other. And with that property, if you can make one angle is 90, then obviously, automatically, all other angles also become 90. So, an angle, one angle is 90 in parallelogram, that is, turns to rectangle. Okay? Next one. Yeah, of course, if in parallelogram, one angle is 90. A parallelogram with one angle is 90, then it is a rectangle. Yeah. Next, rhombus. Rhombus, if you see, opposite angles are equal and adjacent angles are supplementary to each other, but the diagonals bisect vertex angles. Whereas these two cases, like parallelogram and rectangle, diagonals do not bisect vertex angles. But whereas in rhombus and square, diagonals bisect even vertex angles. So diagonals acts as angular bisectors of vertices. But here, they are not angular bisectors of vertices. Okay. Next, in square, each angle is 90 and diagonals bisect at 90 degree, right? And also diagonals bisect each angle. Like already 90, I mean each angle is 90. So when diagonal bisects, then it bisects as 45-45. But in rhombus, we are not sure it is 45-45. It can be any. But here in square, it is pakka 45-45. In rhombus, it will just bisect. If it is 60, 30-30 it will bisect. But in square, always 45-45. Okay?
ABCD is a square and CED is surmounted on a square, which is an equilateral triangle. So now indirectly ABCD is a square where AB is equals to BC is equals to CD is equals to DA. So already ADC is given equilateral triangle, and hence even D and DE and EC are also equal to all these sides. This much we are given. And join AE, join BE. Using this, prove AE is equals to BE and angle DA is 15. Let's understand how to do. AE is equals to BE. Directly we cannot get AE is equals to BE, but we have congruency. So where AE and BE is considered, and we'll also talk about congruency. AE I want for a triangle, AE should be a side and BE is a side of another triangle, right? Then if I can prove both are congruent, then by CPCT those sides like AE and BE are also equal. Here ADE one triangle and BCE another triangle, where AE and BE acts as sides of two triangles, right? So now, what are congruency rules we have? S, 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 SAS, two angles and side. Fourth, RHS. Here SAA also, RASA also, all are same here. Indirectly here, two angles, one side. One angle, two sides. Zero angles, three sides. Here, one angle, two sides. In this case, direct. In this case, direct, anything is fine. But in this case, angle should be included. Angle should be included. If two sides and one angle is given, that angle should be included. In case that angle is not included, that must be another property, which is RHS, where right angle is not in between sides. It is not included. Then one side should be hypotenuse, the other side is anyways any of the sides, height or base, and one angle, whatever the angle, that angle should be 90 degree, right angle. Okay. So whenever angle is there, one angle is only given, that should be included. If that is not included, that must be 90 degree and it is a right triangle. In that way we should consider. Understood? Yeah. So now out of all these four, from triangle proof, yeah, from triangle ADE and triangle BCE, AD is equals to, in this AD is equals to another triangle BC, and in in this triangle DE is equals to CE. Very good. And now correct, see, angle ADE is equals to 90 plus 60, because this is a equilateral triangle, each angle is 60 degree and this is anyways 90 degrees, which is equals to angle BCE as well. So now we have side, another side, and angle. So two sides and one angle. If two sides and one angle, make sure that angle is included. As it is 150, which is not right angle, that angle must be included. Then only by SAS both are congruent to each other, otherwise they are not. Now let's see whether that angle is included. See, ADDE in between angle. See, ADDE in between angle, angle D. So it is included. BC and CE is included. Common angle BC CE, which is common, that is included. Now it is also included, angle BC. So therefore by SAS congruency, we can say triangle ADE congruent to triangle. Here A with what we don't know for now. Okay, then we should understand from here. A is B or C, or D is common in these two. Let us see D first. D, B or C. D goes to B or C. Here D goes to B or E or C. So D should be C. I'll first say fix D as C. Then A should be B. Okay. Then E should be E itself. So ADE is congruent to BCE. This is very important. Okay. Representation is important. In this case, luckily, these two sides are also equal, no issue. Sometimes these two are not equal. Make sure representation is very proper, which are corresponding, because here always we talk about corresponding parts. Okay. Now, if once they are congruent to each other, by CPCT, corresponding parts of congruent triangles. Corresponding parts of congruent triangles. What are corresponding parts? Angle A, this angle B, these two angles are equal. And when we talk about angles, and angle D and angle C are equal, and this angle E and this angle E are equal. And when it comes to sides, AD first two, BC next two are equal. Next DE is equals to CE, DE is equals to CE, and AE is equals to BE. So AE is equals to BE. These two anyways we have. So by CPCT we can also equate AE and BE. Hence proved. Correct? So presentation should be proper. See what is given, what we need to prove, what we have, I mean through by what we can prove. That you just make a rough note for your understanding and prove which two triangles you are considering. So that make sure that sides whichever you are going to prove, that should be part of those triangles, and prove them this way. And next, this is just we're done with the first part. What is second part? Angle DAE is 15. DAE is 15. If you clearly observe from triangle ADE, what you can say? Angle DAE is equals to angle DEA. Why, tell me? Isosceles triangle, no, it is. See, AD and DE, in this ADE triangle, AD and DE are equal. Two sides are equal. Then it is isosceles. If it is isosceles, then angle DA is equals to DEA. Yeah. Already we know angle DE is 150. Then this angle should be, sum should be 30, right? Because already 150 is gone by angle sum property. Then this angle plus this angle should be 30. So therefore, angle DAE plus angle DEA is equals to 30 degree by angle sum property. Now what we want is DAE. So DAE you just make it as it is, and DEA you convert into DAE because which we want now is 30. Then 2 times DAE is 30 and angle DAE is 15. Got it? So whenever you take up any sum, just understand the sum first. Read the question properly and how it is taken. And same type of sum, we have even another equilateral, another model is there. I'll just give it here. You keep trying. We'll discuss some day later. Square will be given A, B, C, D. ABCD is a square, and an equilateral triangle drawn on diagonal as one of its sides. So this is an equilateral triangle. ACP is an equilateral triangle. Now these sides are equal and these sides are equal. Got it? So this is another model. See, now equilateral triangle is drawn on side of a square. But in next model, they may also ask equilateral triangle is drawn on its diagonal, one of its diagonals. Anyways, it is a square. Both diagonals are equal. Any one diagonal you can take and draw an equilateral triangle. Okay, one or the other same. I took here AC as a diagonal. You can take BD as a diagonal and try. Okay, this type you check for the model and then solve. Okay, if you have doubt, let me know. Thank you.